2 updates in 2 days. This has got to be a record. Just goes to show me, yes, that I'm on the right track. So shortly after making the video about the NPC movement, I decided to get that all squared away, put that kind of to bed for the time being, and to move on to something else. The next step that I want to work on is getting the player to be able to dock at stations, just like NPCs, so that eventually I can get working on the market and some of the initial market UI, which I actually have waiting in the wings. It's not pretty, it's not ready for prime time, so I'm not going to show it. But in order to do that, I do need to get the player kind of into the game and working. One of the biggest thorns in my side has been trying to figure out how to deal with movement for the player. With NPCs, it's pretty easy. You just turn them to look at their destination, and you just tell them to move forward. And then, as I said in the other video, as soon as they get within a certain distance, we just do whatever it is we need to do. Players, however, a little more difficult because there are different control schemes. So first off, you need to figure out how you want the player to be able to move around. Because this is a space simulation game, it's not a space simulator like Elite Dangerous or Star Citizen or anything like that. So it's not going to be, you know, HOTAS joystick and throttle kind of setup. It's a casual kind of, you know, movement game. So there's two, you know, maybe a 2+ solution. The first being keyboard, in which case you would use the WASD and or the arrow keys, as well as maybe the Q and E keys, to kind of move, to control the pitch, yaw, and roll. The pitch being the nose moving up and down, the yaw meaning kind of spinning around on the central axis, and the roll, of course, being, you know, spinning around on an axis that runs from, you know, the fore to the aft of the model. The other option is to get the mouse working to kind of allow you to fly the ship. If you try and do a combination of these, then you start getting into some weirdisms. Like if you use the mouse, well, then what do you do with the mouse pointer? If you want to be able to allow the user to click on things, then you're going to have to free up that mouse pointer in some way, which means the user will probably have to have control over the ship when the mouse pointer is not in locked mouse control mode. The plus option, of course, is a gamepad. I do have an Xbox One gamepad here that I can try, but I haven't quite gotten that far. I do want to include that, since this seems like a natural kind of game for that, at least for the control. I have to keep it in mind for all of the menus and all that other business if I choose to go that route, but that is the plus option. Right now I'm trying to get the rudimentary scripts down, because moving requires a lot of math, and a lot of the math functions. You start dealing with things like, I don't know how to pronounce it, quaternions or something like that, Euler angles. Then you start dealing with rotation, and of course rotation in relation to the world or to the object itself, and you have to get all of this stuff straight. You may not use it all, but you need to know when presented with it, you know, what each means. I still don't. Okay, and it's still pretty kind of black box to me. Math's not my forte, of course, but getting the player movement was really important. So what I did was I actually came up with a small, very small script here, and it's super. I've pulled it out of kind of a whole bunch of different resources from the internet. And what we do is these are values here which control our various speeds. So we've got, you know, your forward speed, your reverse speed, how fast you can go maximum, how fast you can go in reverse maximum, as well as how quickly you roll, how quickly you pitch, and how quickly you yaw. We also have a Boolean that will allow us to turn on and off the cursor. So the junk right here in this update statement now, the update of course, fires once every frame. So when you're talking about 60 frames per second, this will fire 60 times per second. So what we're doing here is essentially we're allowing you to toggle the mouse. So you press the space bar, you free the mouse, you hit the space bar again, you lock the mouse. And when you lock the mouse, you're in the mouse look mode. And then when you're in mouse look mode, that's when you get control over the ship. So I've resorted to using the scroll wheel for your thrust. And as you wheel up, you'll go faster. As you wheel down, you'll go slower. And if you wheel back far enough, you'll start going in reverse, which, of course, for a spaceship is kind of stupid. So we'll eventually nip that in the bud. But this stuff right here is all very super duper kindergarten grade simple movement code, which essentially takes the scroll wheel for your thrust, calculates your yaw, pitch, and roll based on mouse movement. So side to side, forward and backward for the mouse. And then I do have a horizontal mapped to the A and D keys so I can actually roll, because I've noticed that using this particular scheme, moving around with the mouse, you do tend to kind of roll to one side or the other. So the A and D keys will allow you to correct that to get it back to whatever you would consider to be horizontal. When you're dealing with 3D in space, horizontal is kind of a matter of perspective based entirely on what it is that you're facing. If you're facing an object, you'll notice. If you're just facing out into deep space, you're not even going to notice whether you're horizontal or not, because there's no reference. Then the direction basically is taking all three of these items, turning them into a vector 3, which is a three-part indicator in 3D space, of course. And then we rotate based on these values, and then transform translate essentially moves us ahead based on our scroll wheel value. So what does that look like? Well, here we have our ship. It looks kind of like a surfboard. In the game view, actually, it kind of looks a little less like a surfboard. It's a cylinder, which was flattened and elongated, because I needed to know more or less what direction I was facing in. So according to this little gizmo right here, you'll see that forward is facing in the Z direction. And that's important because when you're dealing with forward, it's not always necessarily what you would logically consider to be forward, meaning the front of this particular object. It's weird like that, and it's another one of those mathy things you have to kind of come to grips with when you're dealing with this stuff, and that's been kind of a pain in the butt. I know that when it comes time for me to import a model, I'm going to have to pay attention to this, because importing a model and having it face in the proper direction, I've tried it in the past, and it's really kicked me in the ass. So this is just a very simple thing. And of course, we still have our elements from our previous demo. We have our jump gate, our 2 stations, and our asteroid belt. So what we do here is we're going to play the game. So we're maximized now, and right now I've got my pointer here. Here's my ship, my asteroids, and over here is a station. We are kind of in a weird camera mode because the camera, I guess, has got a really weird field of view going on, but it's essentially it's just what it is. This is a test. So when I hit the space bar, what's going to happen is the mouse pointer is going to go away, and it's going to lock it so that my mouse pointer now will control the ship. So if I move the mouse to the left, I'm going to turn in this direction. If I move it to the right, of course, I'm going to turn to the right. If I move it forward, I'm going to pitch up, and if I move it down, I'm going to pitch down. Now, one of the great points of contention between my friends and I is that inverted mouse versus non-inverted mouse. It's actually taken me quite a bit of time to futz with these settings to actually get the mouse behavior to translate into what I personally like. It's been a little confusing, but this is more or less how I like it. When you push the mouse forward, you go up. When you pull the mouse back, you go down. Swing to the left, turn to the left, swing to the right, turn to the right. Now you notice we're not rolling, we're simply yawing and pitching. And that's fine. When I do the A key, I will roll this way, and when I do the D key, I will roll this way. And that's important because if you notice, when I turn here, now the horizon is kind of skewed. So essentially, I would kind of want to reorient myself. I'm not entirely sure. That's because, again, of my crappy, super simple math, not taking certain things into account to kind of normalize. But in space, it's not going to matter. So we're sitting here kind of in the middle of nowhere, not going anywhere. What I don't have on here is an indicator for my speed. So actually what I'm going to do is I'm going to minimize, I'm going to pull this actually out of here, and I'm going to turn off maximize on play so we can watch the inspector. Now the inspector for this cylinder, which represents the player, we got this value here called current thrust speed. I don't know how well that's showing up on the it's going to show up on the video, but the current thrust speed is a factor of 1, because every time I roll the mouse wheel, it's going to increment by 1, and then it's going to multiply that by 5. So every time I click the mouse wheel forward, it's going to increment my speed by 5, and that value is stored into the current thrust, and it's maintained until we roll backwards, at which point it gives me a -1 times 5, so we subtract and we slow down. So, where'd my play button go? Alright, so let's play that again. We'll take a look at the current thrust speed. So we're going to hit the space bar, we're going to rotate, and then we're going to click up once. So now we're going at a speed of 5, 10, 15, and as you can see, we use the mouse and we can go ahead and fly around a little bit. We can actually fly around all of our items. Right now there's nothing going on with them, and as you can see, I kind of got knocked off course because I've got rigid bodies on. And with a rigid body, we're using physics, and now I'm kind of spinning out of control. I have no way to really kind of stop it, probably because it's under the control of physics right now at this point and not under my actual control. So we just got to be careful. That's something I do have to fix. So we can speed up quite a bit, 35. I do have it locked right now at an arbitrary 100 speed. There's nothing to actually stop it from going beyond 100 though. Obviously this is kind of fast, and when we're talking about traveling through space, I don't know if this is really the kind of speed I want. It's all going to matter. It's all going to be different based on the distance that these objects are from one another. That's a good way to give an illusion of distance by not necessarily spacing them out at a proper distance, but by controlling the speed at which you travel. So I have to really play with this, kind of give the illusion that you're traveling really, really fast, even though you're technically traveling really, really slow, and that'll give you the feeling that you're kind of moving great distances. So that is my super simple movement sample, and I was actually really, really pleased that I came up with that, at least for testing purposes. So I can go ahead and get this working. I can commit this to source control with a with a smile on my face, because it's going to at least allow me to continue on into the next section, which is to do player interaction with jump gates and stations.